Hello everyone, welcome to Code with Femi. I hope you guys are well. I hope you guys are doing great. It is amazing to always have you guys on my channel. In this video, we're going to be looking at object-oriented programming. Object-oriented programming, for short, is OOP. And this is you actually, thinking about the concept of being able to like organize or structure your software around your objects and data rather than you focusing on your functions and your logic. And the reason why this is actually good is because this enables you to actually develop your program in a modular form, in a modular way, where you can actually create building blocks. You can break down like complex problems into like smaller bits, and you can solve them as you go along. Let's take for instance a calculator. For instance, a calculator, you want to think about the computing things that you can do, like multiplication, like addition, subtraction, division, and all that. Like you want to be able to break those things down into smaller sections where you can actually solve them, and once you solve them, you can easily reuse them wherever you want to. Like, let's say for instance you have a module that actually adds two numbers together. You're always going to have that, and anywhere you need to use that actual function, you can easily call it. But the whole idea is that you should always remember that OOP helps you develop a much more robust software. It helps you to be able to have a software that can easily be scaled. You can scale it up, you can add new features to it. You can actually also like be able to ensure that it's flexible. It's pretty flexible to some extent. And you can see right in front of me here, like we have this actual document we're gonna walk through. And one of the key things that you need to bear in mind is that there are actually 4 pillars. So OOP has 4 pillars, and these 4 pillars are encapsulation, abstraction, inheritance, and polymorphism. You see, these 4 things are actually the key pillars of OOP. If you can actually understand them, then you should be able to write your code using object-oriented program. When they ask what is object-oriented program, you can easily tell them that yes, this is what it's all about. It's all about encapsulation, abstraction, inheritance, and polymorphism. And you can even go into details, because this is one of the key things they even ask you in interviews. And in this actual video, we're going to be looking at each of them, and I'm going to also be showing you some code examples just to let you understand what it's really all about. So let's start with the first one, which is encapsulation. Encapsulation is actually you binding data members and functions into a single unit to prevent external access. So what this means is that in a class you actually have fields, and you want to be able to control the how other classes actually like access those fields. And you have like functions that can also help to actually expose or not really expose, but help you like change the state of that actual class. So an example is this. If I'm gonna switch to Visual Studio. I've actually prepped up a console application for us just so that we can actually save time. Like, let's just add a class, and this class we're gonna give it a name, call it encapsulation. right? We call it encapsulation because we're dealing with encapsulation. Let's make this public. And you'll be wondering, why am I making this? Why do I have to put public here? The reason why I have to put public here is because I want this class to be reused by another class, because we're going to be using it here in the program class. So the encapsulation is actually, basically, like I mentioned, you controlling how some of the members are being accessed or are being manipulated, or the state of the actual class is being changed. So what I'm gonna do now is I'm just gonna create a simple field. I'll call this animal, right? Animal. And then this is an animal field, and what I want to explain quickly here is that we have a program class that will be using it. So I'm going to come in here and just say encapsulation, new encapsulation. Yeah. And then if I do encapsulation dot, so when I say dot here, what I'm saying is that I'm trying to expose this actual I want to see what members I can call. And as you can see, the only members I can call are these ones: equal, get hash code, get type to string. These are the methods you can override. But basically I really want to get to this guy. This is what I care about, this actual guy, animal. But how can I actually get to it? This is where encapsulation comes into play, because this actual field is hidden from external classes. So what this means is that I need to set up a function that can actually, or a method to help me change the state of this animal. And how you can do that is you can have a public method. Let's call this set animal, right? And we'll pass in an argument. We'll call this animal. And in here, we want to set the private field to the animal argument that will be passed into this method. So right here, I've actually provided an entry point to actually change the state of that actual private field. If you go back to my program class and I click on dot again, you will see that the new method is available. This actually tells me that, so all this tells me that these are all public methods that I can actually call from another class. So you can see that's why set animal is actually is accessible to me now from another class. This is a program class and this is encapsulation class. Let's just break this screen into two so that we can see what's going on in the two classes like parallel. But you can see there, if I for instance, if I change this for instance to a private method, like I want it to be private, what this means is that if I try to do dot here, I would not see set animals anymore, because this actual method now is only accessible within this class. I cannot access it anywhere else. But for this actual first pillar we're dealing with, is encapsulation. For us to be able to set that field to actually update the data or manipulate the data of that field, we actually have a function that actually does that, which is set animal. So now I can now call set animal and actually pass whatever animal I want to set. So I'll call this a dog. And this is what I want to do. I want to console in the encapsulation class and output the actual, I want to print out what that private field actually has at this point after we've set it. So I'll put a breakpoint here and I'll put a breakpoint there. Let's actually run this and you will see what I mean. So as we run in this, just know that basically encapsulation is all about how you actually hide your internal members from external classes, and how you can also control how they update the data. So yeah, we've instantiated encapsulation class, and the next line is to actually call that method called set animal. We'll go into it by pressing F11. That actually goes into it. You can see here that what I passed in was a dog, right? And then move on to the next step. Now at this point, line 16, I'm actually setting the argument value to the private field. Then go to the next line, animal underscore animal now, which is the private field, now has a data called animal. Called dog. It's called dog, right? And then if I say continue, what you can see in the output is dog. You can see there that we have dog there, right? So I hope you're getting the concept. So basically we have that. So now let's say, for instance, I need to now get, but I want to get the, the actual value of animal outside of here. So how do I do it? Basically, you just have to implement another function that will do that for you, which is so this one will be a string. We'll now say get animal, and then what you want to do is you just want to return that animal after it's been set. Okay, and then in here, so I don't need this anymore, since I'm going to be, we don't need that anymore since I'm going to be setting and getting it here. So what I can do is I can say animal is equals to encapsulation dot get animal. So this is how I'm getting it. So this is a setter, this is a getter method, and then in there I can now console dot write line dot animal. In here, once I run this now, what you would see now is that when I run this, you will see now that basically we're able to manipulate this actual field by using the methods and not actually calling, explicitly like setting the value here of this field in an external class. Basically using the method to do that, and that actually gives your code some sort of like a structure, which is basically very good. So when we run this now, you will see that I'm setting a dog, and then I'm getting the actual information of that dog at that point. So if you go through this line, instantiate, we set the dog, and then at this point I'm getting a dog. If I say continue, this would give me still a dog. Let's actually change this to a lion so you can see what I mean. Lion, and then I'm running this, and then you can see that that is actually working as expected. So let's just continue. If I expose this now, you can see there, right there and there, this is actually like running, like it's lion. You can see there. So that is actually what you should understand about encapsulation. And as part of encapsulation, it's called data hiding. It's that's what they call it as well. The way you hide your data and the way you actually control its state as well. It's actually one of the key things you have to bear in mind. But this is actually the the basic rules of encapsulation. So let's move on to the next one. Abstraction. So abstraction is the next one, which is actually another one that I want you guys to always have at the back of your mind, which is basically you really don't want to show all the information in a class. You want to hide some of the irrelevant information and actually just display the essential information that really matters. Okay, so and I'll actually give you an example of what I mean by that. So abstraction is just about keeping things away, that keeping away the noise, don't really just you have a class and you're just writing everything and it's all noisy, everything is just happening there. No, try to actually isolate those, abstract those noise, put them in an actual place in a different in the different section, and actually just call them. It makes your code much more neater, and as well as the fact that those things you've abstracted can still be reused in a different part of your actual application that you're writing. So an example is this. Let's go back to the actual the code base again. I'm just going to create a new class. Let's create a new class. Let's call this class abstraction. I'm just going to call this class abstraction. Abstraction. Yeah, abstraction. I'm gonna make it public as well. Okay, and then what I want to do is let's just close this for now, and let's move this to the bottom as well. So we have an abstraction class, right? And what we want to do in this scenario is that I want to create this. So I want to say we have a situation where you still have a private field, And at this point I just want to make this like int. I want to come up with a different example, and let's make this total. Okay, and then in this one I'm going to create a simple actual method to actually set or let's just call this add. Let's call this add, and then I'm going to pass in a, and then I'm going to pass in int b. So this is actually just for adding. So you're adding here, right? So which is you're saying to add. I'm just going to return let's just add. So I'm going to create some further private fields here, which is private a, int a, and then private underscore b. And then what we're doing is I'm just setting a underscore a is equals to a, and then underscore b is equals to b. And I'm saying total is equals to underscore a plus underscore b. So that's what I'm doing now. I'm actually just doing that. So basically I'm doing an addition here. And then what I'm doing is I'm now saying public. I'm just going to create a new method quickly, and just say int, and just say get total, and then that returns total for me. So let's just instantiate that. So abstraction is what we're dealing with now, and that is what we're just gonna quickly just like use here. So we change that class to abstraction because abstraction is what we're dealing with now. Abstraction, then we say in abstraction, copy that guy out, and then we say add. So we add in two numbers together. Let's add 2, and then let's add 5, right? So what we've done is we've done addition, right? And then what we're doing is we're actually now saying at this point I want to get the total, which is equals to abstraction dot get total, right? And then I get total. So 2 plus 5 is equals to 7, right? We can just console log the stuff here. Calculation total, then we can just say 7. Just gonna use string interpolation here because I want to. That's one of the things you're gonna learn at some point, but yeah, this is how you just do in string interpolation. Interpolation. You can concatenate the strings as well if you want to, but we'll get to all that maybe later in a different video. But we have abstraction here, and you can see here that I have add, I have get total. But if you check this actual method, this method in this program class, you can see that you're just writing just single lines, like basically you're saying add, you're saying get total, but in actual sense what you're doing in the actual hood is all of this. So picture all of this being sticked. Instead of you doing this, for instance, now, and you're doing everything like this here, like you're doing all of this here, just picture this, and you see that you're abstracting all of this stuff into a different section, and you just calling the method that does the addition. So this actual addition can actually also be reused. Let's say you have another class that needs to do addition. You don't need to actually now write that same logic again there. You can just call add because you have it. So that is one of the the actual beautiful thing about abstraction. You abstract things that you definitely know that it's gonna be useful for other for other scenarios. So yeah, we have add, and you see we have get total. If I actually run this, you actually see what the output would be now. So basically just bear this in mind, that these are the key things of object-oriented programming, where you're doing all this nice amazing stuff, and you just want to see how how they tie together. But you can see here now that calculation total is equals to 7, and this is Amazing. Like this is your like this is the actual method that is consuming that abstraction class, but the abstraction class is actually the one taking care of all the different, like all the different logics, and this actual main class is just calling the methods in there, which makes your code very neat, very clean. And this logic is here. If for any reason it has to change, it actually just going to change in a single place. It doesn't have to change there. Let's say you have a new class that has that same logic, you have to go change it there. You don't have to do that. You change it in one place, and the actual update would be for everywhere you're using that actual method. So that is actually it for abstraction. Let's move on to the next one. Inheritance. This is actually the ability of a class to inherit the features of another class. This is also one of the key pillars of object-oriented programming, where you have a base class that has some certain things that you want to inherit or reuse in another class, and inheritance helps you to do that. Basically, you don't have to always keep on writing the same thing all over and over again. You can actually just reuse the same existing structure that is in place, and we'll actually do the example right now. I'm just going to let me just open up my Visual Studio again so that we can actually see what's going on here. I'm just going to clean up this one, which is my object, the abstraction that I've done. And in here, I'm just going to do things a little bit different here. So I'm going to say, I'm just going to use a lion as my base class. So using lion, so lion is actually the actual, see this as a parent. This is the actual parent, right? So let's make this public. And one of the attributes of a lion, it's actually it roars, right? Let's say that we have a public void. We're just gonna call it void and just say roar. Okay, and then we're just gonna, for this one, we're just gonna console dot write line, and then we'll actually make it do to do what it needs to do, which is right, like that, something like that. So the next thing I want to do is I want to create a new class, and this new class is going to be the child class to this lion, which I'm going to call a cub, right? Because a lion gives birth to a cub, right? Hope I still remember all of this, but yeah, cub, right? So cub is going to, let's bring down lion, let's take away abstraction, let's just have lion there, let's have the cub up there. It's fine. But inside of the cub, I just want to inherit lion, right? So I'm inheriting lion. And then what I want to do here is that I want to be able to roar as well, right? I want to roar. The cub as well also roars, right? And the actual thing is, if you see here, for instance, what I have here is the cub, and you'll be wondering that, okay, so now, like, so I don't need to write any code in here. Yeah, it's actually right, especially if, for instance, you're not actually changing the state of this, but basically maybe the cup actually like does things like for instance, it does things like drink milk, maybe from the mommy. The actual cub is actually going to be drinking milk. Okay, that's an attribute to this space. This is actually a feature of this actual cub. Or a cub is still a baby, and they still need to rely on milk. So you can just say drinking milk, right? Or we can even rename that that method to drink, for instance. Let's just say drink or eat. I don't know, let's call this eat, and then let's make this like that. For now, let's forget about let's not worry about the further attributes of a lion for now, but I just want to focus on the core. But now what I've done is I've actually inherited a lion, right? A cub has inherited a lion. So if you check this, how many attributes do you think a cub has now? Like, how many methods do you think a cub has? A cub has 2 methods now because it's been able to inherit this actual method from its parent class, which is the lion class. And that is what the beauty of inheritance gives you, because now you don't have to now write raw here as well. If the actual base class already has, the actual raw, like, you don't, there's no point, you get. So there are cases like that where you have a base class that does things that are actually specific, or that are actually generic to the other the other derived classes. So you don't really want to keep on writing the same code everywhere. You can have a base class for that, and then inheritance actually kicks in for you to actually take care of that. And let me show you what that means in this scenario. So yeah, if I say cub is equals to new cub, right? So let's just move this actual cub down so you can see for yourself that it's not like I've made any changes there. It still have only it here. That's what you can see here. But if I do cub dot raw, and you see that I was able to just inherit the parent class immediately, and I can use the method in there. If I run this, you will see that the actual cub is going to raw, and this is because this is actually an attribute of the parent. You can see right there. Basically, it's actually as simple as that. And if I actually go to the actual lion class, let's just copy this. Let's make this actual lion raw many times. Okay, raw. Okay, and then let's run this again. You will see that the actual cub as well will do exactly the same thing. It's like inheritance. That's how inheritance works, and it makes you actually like be able to reuse those code as you go along. You don't have to change it in many places, just change it in one single place, and then you're good to go. And also you can see here that cub can now eat, because these are the 2 attributes that the cub actually has. You can see that it can maybe raw, and then it's hungry, then it needs to go eat, to go drink milk from its mother. Then if I run this now, you can see that it's actually like it does a lot of raws, and then it went to drink. So this is actually it for the inheritance. So let's move on to the next one, polymorphism. So polymorphism is actually, if you think about it, it's it's when you say polygamy, yeah, like many. Poly means many, and then we have morph, which is forms, so multiple forms. That's what you're saying. You're saying that an object can have different behaviors, or it can have different forms. So I will actually show you that. And basically we have 2 types of polymorphism, which is your static compile time, and we have dynamic or runtime one. So in terms of the static and compile one, it's basically around your overloading, method overloading, operator overloading. And then the dynamic or runtime one is actually how you override the base method, how you undo that. Let's just go right straight into this one, and then let's create this actual, let's create the class. Let's call it polymorphism. So polymorphism is the name of the class. Let's move it down here. Much more efficient. Let's clean this up. We're done with that one. And in here we just want to make this class public. Then we just want to create we're doing the first one, which is static or compile time. So we're creating method overloading. We're doing an overloading now, which is int, and then I will just say add int a, int b. So we're adding 2 numbers together. Let's just return these 2 numbers plus b. Right, so a plus b is actually the first method. We'll create another method from the existing one, and then you can see here that it's actually saying it's giving a problem. Once you see underline red, it means that it would not compile. There's a problem with your actual code. So there, just over on it on Visual Studio, and you can see they're saying that I've already added that member. The method already exists. So in terms of overloading, you just have to make sure that the actual arguments are not the same. Like, it has to be different. But the method can actually be, the method name would still be the same. That is why it's called method overloading. So in here, we're just gonna pass an extra argument plus c. So that's what I'm doing now. I'm basically just creating two two versions of the same method. So this method can add two numbers, and it can also add can add three numbers together. So now on the program side, let's just create let's instantiate a class polymorphism is equals to new polymorphism. Then we say polymorphism dot add. So we're adding two numbers now. 1 plus 2 will give you 3, right? So you can just say first result is equals to that. Let's copy and paste that. So in terms of the second one, I'm just gonna change that to say 1 plus 2 plus 3, because now you can see that these are two different behaviors, right? If you think about it, like the first one is adding two numbers, the second one is adding three numbers, but all of these two methods are coming from the same class. So that is what polymorphism is all about. It's changing, the form is changing, it's changing its behavior based on how you're interacting with it. So in here, if I can console what what we've passed in there, just to let you see what is going on. Then we'll just say first result. Let's just say first result. Let's make it capital letter F. First result, right? Then let's just terminate, and then we'll just say second result, and we'll just pass in the second result. And then you can see here that we have this is actually the first type of polymorphism, where your method, you can overload the method, or you can overload an operator. You can see there first result is 3, second one is 6, because we're saying 1 plus 2 plus 3, saying 1 plus 2. So this is actually the first type, which is the static one. And let's just go into this the other one, which is basically we have we have a base. So I'll call this a base one. I just want to let's just remove one of this. We're done with this overloading. We're going to do the other one. I'm just going to make this virtual, right? So make this virtual, and then in terms of add, just going to create a new method here. Sorry, a new class. Let's create a new child class in here. Child class, we just call it polymorphism child. Okay. Polymorphism child, and then that child will override what is in there. So we're just gonna say override. So always remember, the keyword override is very vital when you're playing with overriding things. So when I say override, what I mean is that I want to override what is in the actual parent class. But if you check here, you can see that this actual thing is already telling me there's nothing to override here. What are you trying to override? And the reason being, I have not inherited this class. So remember, you have to always inherit before you can do overriding. So inherit the actual parent class, and then in there I can now do add. You can see now it's giving me that, you see, which is beautiful. So let's say, for instance, now for some reason I really want to add. So in a case where let's say you're adding VAT, I just want to use that as an example. You're adding two numbers together, but you want to add like some tax. Maybe this addition is bank related. You want to add some extra bits to it. We can call this so we can just pass in like a tax in here. So you can actually, before you actually make this call, let's just put in our own extra tax here to say that so we say var base total. So base total is that, right? Base total is still gonna give us the actual number, which is 1 plus 2 is equals to 3, right? But now we want to return so we're gonna return base total. Let's just say plus 15. We're adding 15 to it. So what is going to happen is that when we do the polymorphism here, so now basically the base class will be right here. Always remember, the base class can become a child class, but not the other way around. So you can instantiate it this way to say that the base class now is becoming the child class, and then when you call add, so let's remove the actual, let's just call it result. and then let's remove this. Let's call this result. And then in here you can see that when I run this now, what do you think you're gonna get? What do you think the calculation is gonna be? Just think about it. Well, I'll run it now. So when you run this now, what it's gonna do is gonna say 1 plus 2 plus 15, which is gonna give you 18. So you can see there that this is how you override. So you can override it that way. So this is what polymorphism is, because now you're changing the behavior of the actual object as you go along. Because if I do exactly the same thing of copying the same base class and putting it down here and saying, okay, let's say first, let's just say first result, right? Let's go back to that and say second result, right? And then we'll just make this to actually like instantiate itself, because it can, right? But now we just have to change the actual name there to say polymorphism 2, polymorphism 1. Then we can make that 1, we can make this 2, then we can now say polymorphism result, polymorphism 1 result, polymorphism 2 result. Okay, and then we have first result, then we have second result. So if I run this now, you see that it's gonna give me two different behaviors, even though I'm calling I'm still calling the same method, but now there's an override happening here and there's no override happening in the second one. So the first one will give me 18 and the other one will give me 3. So that is actually it for object-oriented programming. I hope you guys actually got the best out of this. This is how we write most of our software. We follow this actual convention, just making sure that you bear this in mind when you start writing your software. And I hope to see you in my next video, because my next video is going to touch on more further principles. So we're going to be looking at solid principles, how to follow the software engineering principles to actually come up with a much more quality and solid software. And for those of you who have not subscribed, please subscribe to my channel. Like, comment, let me know if there's something you want me to show. I would actually like find some time to do it. And I hope you guys keep well, and I hope you guys stay safe and alive till my next video. Keep well.